Yo, what's up? Um, Today I want to talk about isosceles triangles and the agenda. I want to hit all of these points, hopefully. Okay, so I want to go over the isosceles triangle definition, and then from there see its properties. So let's do that right now. Let me make this full screen. Yikes. Okay, there we go. All right, so what is an isosceles triangle? An isosceles triangle. Uh, Any triangle that has at least two sides congruent, and that just means same length. Okay, so two of its three sides must at least two of its three sides must be the same measure. Okay, so for example, this is a crappy picture, but let's just assume um, if I'm telling you this is isosceles, then then at least two of these sides will be congruent. Okay, and usually they put it like this. These two doesn't really matter, but pay attention to the picture. So when I say this with these two lines, that just means that if I give you one of them, if I give you one of these measures, so if I'm saying this is 18 units or something, okay, then you get the other one for free. Okay. If they don't put these ticks, don't assume that it is isosceles or equilateral because it looks like it, um, because that's not good. There's also a possibility, very slim chance, but I've seen questions where they're not that precise and they forget to make the ticks and stuff, and then they want you to assume it. But yeah, good practice is to don't assume and base it off of the details in the question. They have to say it's isosceles, or you can show that a triangle is isosceles by showing that it has at least two sides congruent. Okay. Um, what else is important about them? Well, actually, in isosceles triangles, uh, not only are the are at least two sides congruent, but so here's another property. Um, the angles opposite these two sides are also congruent. So what does that mean? That basically means that okay, so let me label these vertices. So A, B, and C. This side AB, the angle opposite this side is you look at the like diagonal here, okay? It's this. So this angle here, angle ACB, okay? And then similarly, the angle opposite this side, AC, you look diagonally like this, okay? And they're talking about angle ABC or angle B, okay? They're saying that these are congruent and they make it they use these two arcs to show that they're congruent, and that just means same measure. So once again, if I'm telling you that one of these things is like 17 degrees, then you know the other one has to be 17 degrees. Okay, so you get both. You know, if you know one, then you know the other one. Okay, and just a reminder, the angles here, they're not the same unit of measure as the sides. Okay, so this is degrees usually, and the other one is measuring length. Okay. Okay. What else did I want to say? Okay, so internalize these properties because they'll put these isosceles triangles in um different situations, like inscribed in circles, or they'll put a question of isosceles triangles in graphs, and you need to know this. Okay. Um, what else is there? Okay, so here, sometimes these properties, they're represented as a theorem. So if theorem, just to review what that is, this is just a math fact. Okay, it's a fact. Don't question it. Um, but that's been proven before. Because it's been true, it's been proven true before. Okay, you just take it and then you apply it. Okay, and this is an underrated skill because if you know what this word theorem means, then in you can anytime you're given a theorem, no matter what math sub branch of math, then you can just apply it. I'm assuming that you are given the hypothesis, the initial conditions and stuff, okay? So please remember that, okay? So here, if you Google isosceles triangle theorem, they'll say something like, if a triangle has two sides congruent, then the angles opposite to a piece, okay? Them are also congruent. Okay? Um, you could also say this another way. You could say an isosceles triangle has its at least two sides congruent, and then it's they call them like the opposite angles. I think they're sometimes called base paired angles. Okay, but yeah, what else is there? Angles. Um, yeah, and then also remember if you know, you could also be given a triangle like this. And if you know that these are congruent, let me change this up. So let me say this is 30 degrees and this is 30 degrees. Then following the opposite pair, then this side has to be congruent to this side. Okay. So it's kind of like lopsided. So whatever this is, if I say this is X, then this is X. That's an X. Okay. All right. Now, special case. Isosceles right triangle. Where do its dimensions come from? Okay, so if you Google this, you can see um they'll give you an isosceles triangle. So here, let me write this. So isosceles triangle, wait, right triangle. So the way you think about this is it's two adjectives so it's two describing words and it describes this triangle, okay? So this right means that it has a right angle, and this isosceles means that what we said before, at least two sides are congruent, okay? And when you get this picture, let me try to make it drawn to scale, okay? So let me draw an isosceles right triangle here. Okay. So it has a right angle, right? So let me put the right angle here. So let me give these names, ABC. Okay. And it has at least two sides congruent. So let me choose these two to be congruent. Okay. And yeah, so here in this drawing, you don't know how long AB and AC are. Okay, so you could think about this, when you don't know something in math, just give it a variable, right? Just as a placeholder. So call this X and call this X. Okay. And now you can describe the side lengths in terms of X. Well, actually, if you Google this, by the way, they'll probably put this triangle like this, just a heads up, but just know that this is the same thing. Okay. Um, so here, the dimensions of an isosceles right triangle are going to be x, x, and then this hypotenuse is going to be, they write it x radical 2, but I'm going to put it like radical 2 times x. And notice this x is not underneath the radical, okay? So let me just make it times here just to clarify. Okay. Um, and we're going to see why. Okay. So, um, question is, why are the dimensions like this? Okay, so if you want to understand this, you need to know these topics. So Pythagorean theorem and combining like terms. Um, yeah, that's basically it. Okay, so Pythagorean theorem that says that in a right triangle, okay, so in any right triangle, so here's another one, and I drew it the right way. Okay, so here, the common way. So let me call this X, Y, Z. Call this A, call this side B, and call the hypotenuse C. This is typically how it's drawn. Um, it's saying that the square of the hypotenuse, so let me just write it like this. So it's A squared plus B squared is equal to C squared. And what this is saying is that the square of the hypotenuse is actually the sum of the squares of the individual sides of the two other legs. Okay, so you're basically applying this here. Okay, but this is a little weirder because I didn't draw it this side, okay? All right, but let's just apply this. Okay, so here, you have to find out who the A and the B are. Okay. It doesn't matter if you want to call this one B and call this one A, but this hypotenuse, this does matter. Okay, so don't change this one. And to know which one is the hypotenuse, you have to first locate the right angle and then look at the side opposite the right angle. Okay, so here we're applying this thing that we did here. Okay, so then this x side xz, that's a z, that's the hypotenuse. Okay, so applying this trick here, find the right angle, okay, and then now find the side opposite this. It's got to be here. Okay, so that means side BC is the hypotenuse in this example. Okay, so so here this is, we know that this is a fact, okay, about isosceles triangles, and we're gonna derive this right now. So let me delete this, okay? Okay, so here we know that this is an arbitrary or just a general isosceles right triangle, and that means that at least two sides are congruent. I chose these two sides to be congruent. We don't know the side length, so we're going to give it a place value x, okay, to represent these, okay? If this is x, then this has to be x. And now the question is, I need to find out what this is, okay? And if everything goes right, this has got to be radical 2 times x, okay? So here we apply the Pythagorean theorem, and we know that this is like A. This side is like A, and this side is like B, okay? And once again, you could have swapped these around, okay? So now applying this here, you can say by the Pythagorean theorem, so by the Pyth theorem, you get that a squared, which is x squared, plus b squared, which is x squared, has got to equal the hypotenuse squared. Okay, so let me call that question mark squared. Okay, so I need to solve for that question mark here. Okay, well, here you have x squared, and that's x squared, so those are like terms, and the coefficient or the number in front, there's no key of 1 in front of each of these. So this is like saying you have 1x squared and you have 1x squared, so together you have 2x squared. Okay, so that means it's saying that 2x squared is equal to this question mark, which represents the hypotenuse squared. Okay, and now if you learned in algebra, right? So you see there's a lot of algebra in this question in geometry. Okay, so here to find the question mark, you would have to square root both sides like this. Okay, and when you do that, so let me do it in different color. We know that this power of 2 disappears, so this becomes a question mark. So that's this is the hypotenuse, right? So hypotenuse is equal to this, the square root of 2x squared. But okay, so another topic I forgot to mention. What else do you need to know? You need to know the properties of radicals. Okay, and you should Google this. Okay, so I'm going to use the properties of radicals to simplify this piece. And I know that, so the radical property that I'm using is that the radical of a product, assuming that these are positive numbers or non-negative numbers, and we know x has got to be, it can't be negative because you think about y, okay? That I can split up this into this. So radical 2 times the square root of x squared. Okay, so that's the hypotenuse. And my keyboard's acting weird. Okay, I know it's good now. Okay, and now this square root of x squared, we said that when you take the square root of a square, that just gives you x. So this is x. Okay, and then this front part is square root of 2. So square root of 2 of x is equal to the question mark. And this is what we said. Okay, so I said the square root of, okay, so I said the question mark, which is the hypotenuse, is equal to square root of 2x. So instead of the question mark now, I can just say square root of 2x. Okay, and now we know why. All right. Now, what does this tell you? Or what are the applications? Well, anytime I say you have an isosceles triangle, and I give you one of these, so like if I say if x is equal to 3, for example, then we can find all of its sides, the dimensions, right? So if x is equal to 3, then this becomes 3, this becomes 3, and this becomes this weird number, square root of 2 times 3. Okay, or more commonly they'll write it like this: 3 radical 2, which is the same thing, 3 square root of 2. Okay, but I just put this in front because even though it's not common to do, because the way I think about it is you're taking a scaled up version of x. Okay, and I say this is a weird number because square root of 2 is something called it's an irrational number. Okay, and if you look this up, the value basically nobody truly knows how it looks like, but so basically that just means that the decimal is repeating and it has no pattern. Okay, but the value, it has a bound, and this is approximately like 1.4-ish. Okay, so what I'm trying to say is that in isosceles triangle, the hypotenuse is like 1.4-ish times x. So you can use this as a sanity check, okay, in whatever kind of questions you're given. Okay, so in this situation, if I'm telling you x is equal to 3, then that means that the hypotenuse has to be the exact value is 3 times radical 2. Or if you want a nice little approximation, this is like 3 times 1.4-ish. Okay. So use that to help you. And yeah. Okay. I think that's basically it. Wait, actually, one more thing. If you Google this isosceles right triangle, you might also see this. And they call this a special case. So if you're seeing this as square side length 1 and side length 1, and then you can use Pythagorean theorem to do it this way, and you can see why it makes sense. Okay. All right. Hopefully this helps, and hope you guys have a good week, and I'll see you next week. Peace.